So who is blowing the whistle? Engine. Who is giving out the sound? Engine. The apparent frequency as the train approaches the observer. Actual frequency of the whistle is 1 kilohertz. Newton Laplace equation V is root gamma P by rho. Hello students, this is SD Sir, yet again from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In my today's class, very interestingly, I have numericals based on Doppler effect. If you have studied all the 7 cases I have discussed on Doppler effect in my session, these problems are quite interesting and easy to solve. The first one, the problem says the apparent frequency, apparent. What does the word apparent mean? Apparent means something which is not true or something which is false. The apparent frequency of the whistle of an engine, train. So who is blowing the whistle? Engine. Who is giving out the sound? Engine. So here, engine is treated to be the source of sound. So the apparent frequency of the source, the so-called engine, changes in the ratio 6:5 as the engine passes a stationary observer. Stationary means someone who is at rest. If the velocity of sound in air is 330 meters per second, what is the velocity of the engine? Again, which is the source, which means Vs has to be calculated. The apparent frequency of the source changes in the ratio 6:5 when the source is passing the stationary observer. So in the first case, I consider the source going towards the observer who is at rest. It is going towards the observer, approaching the observer who is at rest. Here, F dash is V divided by V minus Vs into F. When the source goes towards the observer, approaches the observer who is at rest. B, source goes away from the observer who is at rest, passes away, goes away. Here I say F double dash is V divided by V plus Vs into F. These relationships you need to know by heart. When the source goes near the stationary observer, source goes away from the stationary observer. So 7 different expressions are given. Now, F dash divided by F double dash, V and V gets cancelled, F gets cancelled. V plus Vs divided by V minus Vs. This ratio is given. Change in the apparent frequency 6 by 5. This is 330 velocity of sound plus Vs minus Vs, and on simplification Vs turns out to be 30 meter per second. So very easy, students. Just to know the relationships very clearly, you can arrive at the answer. The next one, a whistling train. Again, source, whistling train, train blowing out the whistle, train blowing out the sound of steady frequency 250 Hertz, passes a railway station at a speed of 10 meter per second. So velocity of the source is given. Find the apparent frequency of the whistle for a stationary observer. Again, the observer is at rest on the platform. When the train is approaching and when the train is receding. Velocity of sound in air is 330 meter per second. Exactly as we did the previous problem. In the first case, train approaches andre, it comes towards the observer who is at rest. Therefore, he is called the stationary observer. So here F dash is V, again V minus S into F. So V velocity of sound in air 330 minus 10. So F is given to be 250. On simplification, this is 330 divided by 320 into 250. So this is 257 hertz. So this is the apparent frequency as the train approaches the observer. B. Train recedes him. So again, F dash is V plus Vs into F. So V is 330 again. 330 plus 10. F is 250 again, and on simplification, this is 243 hertz. See again, just the same relation. Numericals vary. I have got the solution at hand. The next problem, students. This is an important one. This is asked in the examination. The frequency of a whistle of a train is 1.1 kilohertz as heard by an observer. Concentrate here. This is not the actual frequency. The observer is hearing the frequency as 1.1 kilohertz. So very clearly, this is giving me the apparent frequency. If the actual frequency of the whistle is 1 kilohertz and the speed of sound is 340 meter per second, calculate the speed of the train and the direction of the motion of the train. The frequency of the whistle of a train is 1.1 kilohertz. Apparent frequency 1.1 kilo is 10 power 3 hertz. As heard by an observer on a platform, actual frequency is 1 kilohertz. Speed of sound V is 340 meter per second. We have to calculate the velocity of the source, which is the train. Again, the same expression. F dash is V minus Vs into F. How much is the apparent frequency given to be? 1.1 into 10 power 3. V is 340. 340 minus Vs. 10 power 3 gets cancelled on both sides. On simplification, this is 31 meter per second. So again, simple to calculate. We have got Vs by using the same expression, but manipulating the expression and substituting what is given. The last one, density of air is 1.29 kg per meter cube at NTP. Calculate the velocity of sound in air at 27 degrees Celsius. The value of gamma is given. So we all know velocity of sound in air is root of gamma p by rho. Established Newton Laplace equation, V is root gamma p by rho. Or on substitution, gamma is 1.4, pressure at NTP 101.3 into 10 power 3 divided by density, which is 1.29. So I have just used Newton Laplace formula, root of gamma p by rho. Gamma is specific heat capacity is given to be 1.4. Pressure is 101.3 into 10 power 3. Rho is 1.29. So V naught on substitution 331 meter per second. But we also know Vt by V naught is root of T divided by T naught. Isn't it, students? In the session we have told this. Vt by V naught is root T divided by T naught. So Vt by V naught 273 plus 27 divided by T naught, which is 273. And on simplification, Vt turns out to be 347 meter per second. So, I have discussed all components of numericals from the problem's waves. Next, I'll be starting with mechanics, problems from one-dimensional motion, also called motion in a straight line. Until then, have a nice time. Thank you.